Dear students, in the last class I have explained the differences between the speed and the velocity. The speed is a rate of distance traveled and velocity is a rate of displacement. Unit of both is a meter per second. The dimensional formula of both is a LT minus 1, and the speed is a scalar quantity, whereas velocity is a vector quantity. So, all these things we have learnt in the last class, and then we have even learned an important term called uniform speed or uniform velocity. So, uniform speed means if a body covers equal distances in equal intervals of time, then we call such speed as uniform speed, and if a body undergoes equal displacement in equal intervals of time, then the velocity is said to be uniform. Uniform means same, constant throughout. Okay. So, now let us learn something more about the average speed and the average velocity. So, when do we take the average? We take the average when the value changes, when the value varies. Suppose if a car moves from a particular location, then its speed continuously changes. Let us consider because of the heavy traffic. So, the speed, there is a continuous change in the speed takes place. Okay, there is a decrease in the speed, there is an increase in the speed, and whenever there is a traffic signal, the speed reduces to 0. So, whenever the speed changes, we use the word variable. Whenever the speed is a variable, we measure what we call the average speed. So, how to measure average speed? So, the average speed, the symbol used for that is a V with a dash above, which we read it as a V bar, is equal to the ratio of the total distance traveled, divided by the total time taken. This is how we measure the average speed. How to measure average velocity? The average velocity, the symbol is same, is equal to, instead of the distance we need to write the total displacement divided by the total time taken. So, average speed is defined as the ratio of the total distance travelled to the total time taken, whereas average velocity is defined as the ratio of the total displacement of the body to the total time taken. So, let me consider an example where, so this is the reference point, okay, which we call origin. Initially, the body is at point A, here it is, which is at a distance x1 from the origin, and it is here at an instant time t1. Then it moves along the straight line and it comes to another position called B. So, this is x1 is the position or distance of the body from the origin, from the reference point at a time t1. It comes to another position B, which is at a distance x2 from the origin, and to move from here to here definitely it takes time. So, therefore, the total time taken is now t2. So, x1 is the distance travelled or the displacement in a time t1, and x2 is the displacement in a time t2. So, the question is, in this case, since the body moves along the straight line, both distance and displacement are equal. Therefore, in moving from A to B, it was here, right? Now, it has come here. So, what is the net distance or total displacement? So, we want this distance, correct? So, we know this much x2, we know x1. So, how much is this? It is x2 minus x1. Hope you have understood. So, therefore, the total distance as well as the total displacement is x2 minus x1. So what is the time taken, for this particular distance? The time taken is t2 minus t1. For example, if this t1 is 1 second, if this t2 is 7 seconds, therefore to move from here to here, it takes 7 minus 1, 6 seconds. That means we have to write in general t2 minus t1. So this is the formula used to find average speed or average velocity. Okay. So how do you measure the average speed or average velocity? What is the formula for that? The average speed or average velocity is equal to x2 minus x1 by t2 minus t1. Where what is x1? Position of the body at a time t1, and x2 is the position of the same body after time t2. Okay. So that is about the average speed or average velocity. So do remember this formula. We'll be using this later while solving the problem. The next one is instantaneous speed. The word instantaneous means at a particular time. The body is continuously moving like this, imagine, okay. Instantaneous speed means at a particular instant, you can say either particular position, particular location, or at a particular time. What is the value at this particular point of time? What is the value? What is the value here? What is the value? What is the value here? At a particular instant. And that is called instantaneous speed. And in the speedometer of the vehicle, what you get to read, what you get to see is nothing but the instantaneous speed, the speed of the vehicle at that moment, at that instant. Average means average over the entire journey, correct? From the beginning till the end, what is the average speed with which you have traveled? That is average. Instantaneous means value at a particular instant of time. That's called instantaneous speed. So how do you measure instantaneous speed? The speed of a body at a particular instant of time is called instantaneous speed. Similarly, what is instantaneous velocity? Velocity of a body at a particular instant of time is called as instantaneous velocity. So how do we measure that instantaneous speed or instantaneous velocity? Okay. So as the body moves like this, I want to find the value somewhere here, okay, at this location. And to find that, what we need to do is we have to consider now not the entire journey, but a very small distance or displacement, which we write it as a dx. Dx stands for a very small value here, this value, a very small value of the distance traveled. For average, we take the total, right? Entire journey. But for instantaneous, consider a small distance, okay, very small distance or displacement, and then you see what is the time it takes. Let us take for that small distance, if it takes a time, again small interval of time dt, then dx by dt will give you the instantaneous speed or instantaneous velocity. Okay. So v is equal to dx by dt. See, for average we measure like this, right? V bar is equal to x2 minus x1 by t2 minus t1. Initial position, initial time. Final position, final time. But for instantaneous, we don't use the initial and the final. But instead, find what is the time taken for it. Okay. Check what is the time taken. Okay. A very small time interval, correct, which is dx, and then divide by that, you will get the instantaneous speed. Okay. So hope you have understood as how we can measure. So therefore, this is the formula for what? Instantaneous speed, and this is the formula for average speed. Average speed. Okay. Right, so let's see the next question. So I have given the two formulas, one for average and the other for instantaneous speed. Okay, so let me write again. So for average, V bar is equal to x2 minus x1 by t2 minus t1, whereas for instantaneous, V is equal to dx by dt. Okay, right. So let's see some more question. The question that has appeared in the examination, so that I have listed here. So first one, define average speed. Question has appeared once in the examination. How do you define average speed? The ratio of the total distance traveled to the total time taken. Define average velocity. The ratio of the total displacement to the total time taken is called average velocity. Next question that has appeared, under what condition the magnitude of the speed is equal to the velocity? When velocity is equal to the speed? When the particle moves along a straight line. That is the answer for that last question. Okay.